Today we'll be talking about some questions from the 2024 paper. Question 13 is a supermarket with 5 departments. The floor plan is represented by the graph below, and on this graph the vertices represent the departments and the edges the boundaries between the two departments. Now the graph is incomplete, okay? So draw the missing vertex and missing edges. Now how I went about this is I actually placed a dot on each of the areas, and these are the locations. That's the vertex, and where I saw a line that went like this was a connection between them. So I actually represented that connection as an edge, and this was connected here. And I also saw that F was connected to G as well, and F was connected to P as well. And then I saw P was connected to F and G. And G was connected to the bakery. So I looked at the graph below, and where it did not show a connection, so D had 2 connections to F and G. So D had 2 connections to F and G. And F had connections to D, G, and P. So F had connections to D, G, and I saw that there was nothing between F and P, and so that is where I draw an edge. What you could also do is, now this had a degree 2, this had a degree 3, this one 2, this one 4, and that one 1. So I rewrote it on the graph that was incomplete, and I saw that F was 3, but I only had 1 and 2. So obviously I had to connect F to P. There are various ways of going about it. Okay. The next question, sorry, the print is not great, but I think if you have a paper in front of you, you should be able to get it. Carla is standing in a promotional department. She wants to visit each department in the supermarket once only. In which department will she finish? And so she's standing at P. Now, wherever you see will finish, it usually refers to the degrees. So if you've used degrees, okay, in the previous part of the question to answer, it should be relatively easy. So currently she's standing at P. So if she was standing at P, if you just go along and you have to visit every location once only, you could either go this way, that way. Nah, that wouldn't take you to B. So we can do this and we will end at B. There is no other option really, because if you go any other way, for example, if you had taken this route, you would have had to come back to G. So any other way, you would have had to visit a vertex twice. So that is, it tells you that ultimately B is the place that she would finish at. What's a mathematical term for this type of journey? When you visit each department only once and you don't come back to the same point, that means it is now, it's like visiting every house once. And house has the capital letter H, which stands for the Hamiltonian, and that's not the complete answer. And because you visit only once and you don't return to the same location, it is called a Hamiltonian path. If you return to the same location, it's called the Hamiltonian cycle. The supermarket adds a new entertainment department E, and the floor plan is rearranged. The boundaries between the departments are shown in an adjacency matrix. Now this is a matrix that shows all direct connections between locations. All direct, all all direct connections. Okay, and a 1 indicates a boundary between the departments. Now the question is, using the adjacency matrix, complete the floor plan below by labeling each department. The bakery is already labeled. Now this took a little time actually, and what I did was I added up each of the rows, and that would give me the degree of each of the vertices. And so it told me B, the order was 4, and so I first checked out, I came from this region and I checked out that this had an order 2, and I saw that 2 was E, and so I placed E over here. And after doing that, I looked at the 3. I saw this particular location had 1, 2, 3 connections. But then when I saw the orders, I saw 3 was in 2 locations. So it could be either D or G. So I placed D or G there, and then I moved on. And then I looked at this location, and I found that it had 4 edges coming off it. Now, when I looked at the adjacency matrix, I saw B and F and P had 4 edges coming off it. Okay, so this could have been F or P. So I placed F or P in that location, and then when I moved on to the other location that I hadn't yet looked at, which was P, I saw that it had 1, 2, and 3, and 4. So that told me that now, because this was giving me 4 as well, I looked at the connections that the 4s had with B. So definitely P had a connection to B. F also had a connection to B. But then I looked at, because I wanted to see if this P location had a connection with D or G. Now P had a connection to, no connection to D, but it did have a connection to G. So then I assumed that P must have had a connection to G over here, and definitely P has a connection to, so that's done. P has a connection to E, and that's this one here. And P has a connection to B, which we know, and P has a connection to F. So that made me place F over here. Now if that was F, F has a connection to B, which we know. F has a connection to D, which we haven't shown. F also has a connection to G. We know G is already here. And F has a connection to P, which we know. That's this one here. Now, the very fact that we haven't shown F has a connection to D implies that this must have been D. So that's the easiest way I found, but I'm sure you'll have easier ways of doing it. It all depends on how you think about things. Okay. Now, question 14. A manufacturer M makes deliveries to a supermarket via a range of storage warehouses, LNOPQR. These 8 locations are represented as vertices in the network. The number on the edges represent the maximum number of deliveries that can be made between the locations each day. When considering the possible flow of deliveries, how many different cuts can be made? Determine the capacity of cut 1. Now, when you look at cut 1, it cuts here, it cuts here, it cuts here, here, and here. Now, of these different edges, the one that has a backward flow is that one, which shouldn't be included. So, if you then add this one, this edge, which has a value 13, this edge, which has a value 18, this edge, which has a value 6, and this edge, which has a value 9. Okay, so let me write that: 13 plus 18 plus 6 plus 9. It gives you 46. Determine the maximum number of deliveries that can be made each day from the manufacturer to the supermarket.